preferably unsorted. If we sort it, what we want to do is then turn it into some sort of sequence. And we can just pick our sequence. Smallest to largest to smallest. In this particular case, we're going to go from smallest to largest. Okay? So these are the numbers 0 through 9 in a sort of random fashion. If we sort them, the end result of all the mad sorting should be 0, 1, 2, a sequence. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And many different ways to sort. If you want to be part of the cool kids, you know we're talking about big O of n. Big O of n is in the world of computer science. It's how we talk about the complexity of an algorithm. Now, I'm going to present to you actually 3 different sorting algorithms. And I did this wrong, really. These algorithms are considered to be O of n squared, which means in the worst case, the number of passes or iterations we're going to have to do is the number of things that we're sorting squared. N squared is not a very efficient sorting algorithm. It does a great job. It will sort it, but it's not going to do it really fast. So if you were dealing with United States Census data, and somebody said, I'd like to have that sorted by income, would you do it? Yeah. How many records are you dealing with? You're dealing with like 360 million records. Would you want to have a highly efficient sorting algorithm? Yeah. Otherwise, it's going to start it running and come back a week later. That's what the answer is, right? So, hey, has anyone ever used Excel?
Yeah.
Okay, you know in Excel, you can highlight a column and sort it, right?
Yeah.
It's using a sorting algorithm. I can't say it's using one of the ones that we're doing today, but it's using something a little similar, right? So we're going to cover 3 different ways of doing exactly the same thing. Sorting this list of numbers and getting it to come out to be smallest to largest. Okay? There's no rocket science. They all approach it differently, and there's different reasons that they approach it that way. We're going to talk about it. We're going to study how it works, and then we're going to look at Python code that actually does it, and we'll actually even run the Python code to make sure that it actually works correctly. All right? Now, I'm also going to give you this code. My gift to you. Okay? And you can do with it as you wish. All right, so let's see what our first sorting technique is. This is the classic. You will see this for the rest of your life. It's called the bubble sort. Okay? So here's how a bubble sort works. So I have a sequence of numbers. 7, 5, 2, 4, 3, 9. And I want to bubble sort it, right? So I want to get it smallest to largest. Well, obviously with that 7 being where it is, that's not exactly what I want to have happen. So what I want to do is basically, what they say is, I want to bubble 7 up to the right spot. All right, that's cool. So how are we going to do that? Well, the first thing that we'll do is, so there's a 7 and a 5. Well, the 5 should be to the left of the 7. So we'll do a little switch. We'll say 7 is greater than 5, right? Yeah, it is. Boom. So we'll do a switch. Next comparison we'll have is 7 to 2. Hey, is 7 greater than 2? Yeah, it is. Switch it. Okay, 7 and 4. Hey, is 7 greater than 4? Yes, 7 is greater than 4. Switch it. 7 and 3. Switch it. 7 and 9. Is 7 greater than 9? No. All right. Woo. So 7 stops. That doesn't go any farther. And guess what? Then we do the same thing for 5 and 2 and 4 and 3. And eventually, when we're all done with this madness, everything is sorted correctly. Woo! Okay. So it works by comparing each item in the list with the item next to it and swapping them if required, bubbling it up to the top. Okay? Keeps doing this over and over and over and over and over and over and over again until it's all done. So if we wanted to do the same thing, we would say, show me some Python code. Bubble sort.
Check is one number by one number.
One number by one number. No more complicated than that, okay? All right, so let's see what we do in our code here. The very first thing we do is we create a list. Oh, have we talked about lists? We have, haven't we? And now they start showing up. I thought we were just talking about them. I didn't know we were actually going to use them. Okay, anyway, so we create a list. Sort list, pretty cool name, eh? Square bracket, and then we do this 9, 2, 7, 0, 5, 8, 1, 4, 3, 6 as individual items, and then square bracket. Poof. So now sort list is a Python variable that contains how many items? Trick question. How many? if it's 0 to 1. 10, that's exactly right. So there's 10 items in sort list. And are they sorted? Are they smallest to largest? No. Do we want them to be? Yes. So whatever we're going to do something with sort list, right? All right, cool. No problem with that. Print out unsorted list for index, in, range, length of sort list. What's length of sort list going to be? Which is what? 10. Exactly. Right. So, for indexes in 1 through 10, print, sort list, square bracket, index, square bracket, comma, end equals quote, quote. What's going on there? Okay, so this first part, sort list, square bracket, index, square bracket is going to print what?
Index position.
Gotcha. So we're going to go stepping through it. So the first thing it's going to print is what? Nine. The next thing it's going to print is next thing. Exactly. So we're going to go stepping through sort list, right? Printing off the individual items. Ching, 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 ching. And we've got this goofy comma, so I guess we'll print a comma after the 9, right? And then we've got this end equals quote, quote thing. So what's going on with that? What does that do? So it keeps on the same line, right? So we're going to print it all out on the same line, right? Boop, and we're done. Fabulous. Life is good. All right. Perform bubble sort algorithm. Okay, well that's something good. All right. So we're going to do this on the board. You're going to see the bubble sort algorithm unfold in front of your very eyes. So list loc, or position in the list, just on that one, is equal to length of sort list minus 1. Okay. Initialize main loop to number of items to be sorted. You're going to see that my code is heavily commented. Just because, again, it's a little weird as to what's going on if you don't have some comments. Okay, so list loc is going to equal to length of sort list minus 1. So what's the list loc going to be? What value? 9. All right, we're good with that. While list loc is greater than or equal to 0, pass index equals 1. Initialize the starting location of the sorted variable. Okay. So pass index equals 1. Okay, cool. We'll go with that. While pass index is less than list loc, by the way, is pass index less than list loc?
That's right, yeah, sorry.
Is 1 less than 9?
Yes.
Okay, fantastic. If the previous list item, if the previous list item is greater than the current list item, switch them. Okay, remember, bubble sort takes a look at this guy, if they're different, switch them. Okay. So if sort list pass index minus 1, so what's pass index?
1.
And if it's minus 1 is what?
0.
So on this list, which location is, what's stored at location 0? So we're talking about this location here. Okay, so that's cool. So if sort list pass index minus 1 is greater than sort list pass index, what is pass index? On this list, what number, what digit, what number is at location 1? Would you agree with me that we're apparently comparing these two guys? Okay. Okay. So is pass index minus 1 greater than pass index? So is 9 greater than 2? That is positive, right? Cool. So now we're going to do whatever the if statement is. Temp equals sort index pass index minus 1. Pass index minus 1 is what? So what character, what number are we talking about here? What will temp equal? That is correct. So we're going to stick a 9 into temp. Pretty cool. Sort index, pass index minus 1 equals sort index, pass index. Okay. Sort index, pass index minus 1 is what, 0? So we're talking about which location? That equals pass index, right? So basically, what are they telling us to do? Well, not even swap. Screw it, just take 2 and stick it in there, right? So 9 goes away, and 2 goes in there. Or screw it, now we lost the 9. Alright, we'll go on, but it doesn't look so good. Oh wait, sort index, pass index equals 10. So what location is sort index, pass index going to be? Okay, so we're going to talk about this one, right? And we're going to set it equal to temp. What's the current value of temp? Thank goodness. Okay? Pass index equals pass index plus 1. List load equals list load. Okay, so point to the next item to be sorted. Oh, okay. So really what we're talking about then is pass index is now 2, right? So 0, 1, 2, so we're not going to point here, right? 2. List load equals list load minus 1. Done bubbling this item, start all over. So list load is list load, okay. So I guess we're keeping track of how many times we have to do the loop. That goes in. And we're done. That's it. So what did we actually do here? Did we switch this location? Okay, now the next time we go through, we won't actually go through it, but we'll just take a look and see how it goes. So we go back up to the top of our loop, our while loop. Pass index equals 1. No, it's this while loop. Here we go. Is pass index less than list load? Pass index is 2. List load is 8. Is pass index less than list load? Yes or no? Yes? Okay, good. So we keep going on our while loop. If sort index, pass index minus 1, what's pass index? 2. 2 minus 1 is what? 1. So if what's stored at this location is less than what's stored at this location, is it? Wait, I said that backwards. If what's stored at this location is greater than what's stored at this location, then we're going to want to do a swap, right? So the next thing we're going to do is swap 7 and 9, is that correct? So 9 started here, it moved to here. Now we're going to swap it with 7. So where's that 9 going to go? Pretty much all the way to the end, right? Whew, it's going to get there, and then we're going to be done with it. Then what are we going to do with this program? We're going to come back and we're going to take a look at probably 2, right? And is 2 going to be less than 7? Yeah, so we won't touch it. Say screw it, fine. We'll move on, right? And that, in a nutshell, is the bubble sort. So now the question is, what happens if we run the code, right? Oh, missed it. So we printed out 927058146. Excellent. Ran the bubble sort, then it comes out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Woohoo! It ran, right? And you saw how it works. So basically, the computer went through and did all these comparisons over and over and over again, right? It was 2 while loops. One while loop processes each one of these locations. The inside one then takes each number and figures out where it's supposed to go. End of story. That's it. That's all you ever have to know about sorting, right? No, of course not. Bright, smart people who are in charge of things like sorting are smart enough to know that there's 1,000 different ways to do exactly the same thing. So let's see. 9, 2, let's take a look at another way to do exactly the same thing. Once again, different sorting algorithms work better in different situations. So that's the bubble sort. Classic way to do it. Next one's called the selection sort. So let's take a look and see what's going on here. Selection sort works like this. You look through the entire array for the smallest element. You look everywhere for the smallest guy. Okay? Once you find it, you swap it with the first element of the array. Okay? So you look for the small guy, you put him at the beginning. In our case, it'll be what? What number will be the small one? 0. So we'll look for 0. We'll stick it at the beginning. Then what we're going to do is we're going to look for the next smallest number. In our case, it's going to be what? And we're going to stick it right next to that one. You with me on this? Then we're going to look for what? And we're going to grab it and we're going to stick it right next to 1, right? Keep doing it, keep doing it, keep doing it. You do it eventually, count, you got the whole dang thing sorted. So this is 29, 64, 73, 34, 20. The smallest number there is 20. Yay, we found it. So grab the 20 and stick it at the beginning. Oh, hey, look, it's at the beginning. Now we look at 64, 73, 34, 29. 29 is the smallest. Grab it, stick it at the beginning. Now what happens is you start searching a smaller and smaller area, right? Because you know everything to the left is sorted and everything to the right is not sorted. Keep looking, keep looking, keep looking, you'll find the smallest number. Let's take a look and see what this would look like in Python. Alright. It's all exactly the same as you saw before. Sort list. We stick our 10 digits, 10 numbers in. We print out the unsorted list. We got no problem with that. Now let's talk about what's actually going on with our actual sorting process. So start load equals 0. So let's break that one. That's going to be 0. While start load is less than the length of sort list minus 1. Okay, so what's the length of sort list? 10. Minus 1 is what? Okay. Is start load less than 9? Darn straight it is, right? Okay, great. So now we've got minimum equals start load. All right, so this min thing. It's going to be the same thing as start load, so that's going to be 0. Next load equals start load plus 1. Equals start load plus 1. So what's going on here? I think I got some comments. Please wait. We'll make the word wider too. So while start load is less than step through the list from first to last position, that sounds like a good idea. This minimum equals start load. Initialize the minimum index to point to the current first location. Okay, so minimum points to the current first location. Right there. Next look. Initialize to point to the next location after the current location, which I guess would probably be like right here. So that's start load. Next. Alright, cool. While next look is less than length of sort list. Sorry, how long is sort list? Okay, exactly. Okay. Keep going until you reach the end of the list. If sort list next look, which is a what number? Is less than sort list min, which is a what? 9. So is 2 less than 9? Is a question that's being asked, right? Okay, cool. We'll go with that. Then minimum equals next load. So minimum now changes to next load, which is 1. Remember the location of the smallest item. Okay. Next load equals next load plus 1. So what did we just do here? We took a look at the first two items in our list. And the question we said is, hey, is the second location smaller than the first one? I think we were actually we said originally the first location is the smallest number we've ever seen. Now we just did a comparison. We said, hey, is the smallest number we've ever seen bigger than the number right next to it? And the answer was, yeah, it's bigger. So now we said, oh great, then this is now the smallest number that we've ever seen. And we're good to go. So we've hit the end of our loop. So now we'll go back up to our while loop. And here we say, while next slope is less than the length of the list, if sort list next slope is 2. Sort list next slope is less than sort list minimum. Is this smaller than this? Is 7 smaller than 2? So then we go to next slope, so next slope plus 1. That goes to 3. We go back up to the top of our while loop. The condition is still there. We haven't gone through the entire list. If sort list next slope is less than sort list min. So sort list next slope is 3. And min is 2. Stop. We haven't changed min, have we? So min will remain at 1. Actually, got that wrong. 0, 1, 2, 3. So the question is sort list next slope, what number is currently at next slope? Excuse me. Next slope is 3, that is correct, but we're using it as an index into our sort list. Nope. Try again, what was that? I thought I heard it. 0. So the question is 0 less than 2? Okay. So if that is correct, then min equals next slope. Next slope is 3. And we'll still order that. Alright. So now what we're going to do is we're going to go to the next slope is 4. So we're going to say, is 5 less than 0? Is 5 less than 0? Is 8 less than 0? Is 1 less than 0? Is 4 less than 0? 3 less than 0? 6 less than 0? Okay. So we think we found the smallest number. Perform switch between the current starting location and the found smallest value. Temp equals sort list start load. Okay, so we now got temp. Sort list indexed by start load has what value at it? Excuse me? 9. That is correct. So that means the temp now has value 9 in it. Yay. Sort list start load equals sort list min. So sort list start load now equals sort list min. So what are we going to do? Put 0 where? In the beginning, all right? Like that? Perfect. Sort list min equals temp. Okay, min is 3. We're going to put temp into it. What it means is we're going to replace the 0 with a 9. Start load equals start load plus 1. So yeah, so effectively what have we done? What we've done now, right, we say this part of the list is now sorted, 100%. Okay, we got the minimum stuff with it, we're all good to go. This is wide open. Now what we're going to have to do is we're going to have to come along here and search and find the next smallest number. Where will the next smallest number be? right there, right? So eventually what we would expect is we'd grab that 1, and we would put it where the 2 is, right? And then we brought it dash line, right? That make sense? So we're just reaching out, grabbing it, reaching out, grabbing it, reaching out, grabbing it. Is this different than the bubble sort? Well, it is. Bubble sort just is a comparison side by side. This one we're looking over the entire list, finding the smallest number and bringing it back. End result is exactly the same. Fingers crossed, fingers crossed, fingers crossed. Okay? But how we do it is completely different. Alright? So shall we run it and see if we got it right? This should be exciting and dramatically different from the last time we did it. So we started out with 927,058. We end up with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it appears as though this algorithm seems to work. Alright. Is sorting exciting or what? I tell you. What?
It's sort of.
Sort of.
Sort of, zing.
Alright, we got one more of these bad boys to do. It's called the insertion sort. Once again, we're going to start with the same messed up list, and we're going to end up with the same exact same perfectly sorted list. But how we get there is where the difference is. So in an insertion sort, what you do is you remove its entries one at a time and then stick them into a sorted pair. So what you really do is you just pull a number off, you stick it at the beginning of the list, and you say, pow, that portion of my list is perfectly sorted. Well, you didn't really do anything, man. You just grabbed a number and stuck it there. And yeah, but it's a list of 1. If you have a list of 1 thing, is it sorted?
Sure.
Yeah. Oh, you get what the number is, okay? It's in proper order. Now, the next thing you do is you grab another number, and then you take a look at the list that you have, and you say, is it greater or less than that one, right? Depending on that, you stick it there. And then you say, cool, now that list is still sorted. All right, well, that's cool. So basically what happens when you do an insertion sort is you start and you build a whole separate list inside the list that you have. And you're grabbing numbers out and sticking them in the right place in your brand new list that you're doing. And eventually what happens is you pulled all the numbers out and stuck them in, inserted them, in the new list in the right place. Pow. That's it. Okay? How hard could that be? Okay, so this one, 29, 20, 73, 34, 64. Pow, we said 29 is a list and it's perfectly sorted because it has exactly 1 item in it. Okay, sort of stupid, but okay, I can live with that. The next thing we did was we went along and we said, great, I'm going to grab 20, which is the very next number, and I'm going to say, oh, okay, is 20 bigger or less than 29? Oh, it's less than, great, I'm going to put it before 29. So now I have a sorted list of 20 and 29. Pow! Completely sorted, thank you very much. Next thing I'm going to do is reach out to 73. I'm going to stick it in here in the right place, which is at the tail end. 20, 29, 73. Bam! My perfectly sorted, brand new spanking new list is still perfectly sorted. Great, what am I going to do? I'm going to reach out and get the very next number on the other side of 73, which is 34. Turns out 34 is greater than 29, but less than 73. I drop it in, I insert it in the right place in my brand new list. Bam! My brand new list is still sorted, and I'm moving on. I'm basically eating all the additional items in that list and sticking them in the correct order in my brand spanking new sorted list. Make sense? Cool. Let's see if we can take a look at some Python code that does this very thing. All the stuff at the top is exactly the same, so we build a list. We print out the contents of the list. Now let's take a look at what we're doing here. Perform the selection sort algorithm. Start low equals 1. Okay, we'll do that. Come on. Initialize the starting location of the sorted list. Okay, good. While start loc is less than the length of the complete list, so as long as we haven't gone through the entire list, because remember, we're going to go stepping through the list, just pulling the next number. We're just going to get the next number out of the list, then we're going to take a look at our pretty little list that we were creating, and we're going to drop that number in the right spot in that particular list. Okay? While start loc is less than the complete list, cool, we'll do this while loop. We're going to try again. Current val equals sort list start loc. Sort list start loc. So we're going to come over here, current val. So what is the value of current val? Excuse me? Got it. All right. Current val equals sort list indexed by start loc, which is 1. J equals start loc. Oh, I'm sorry. So what are we doing here? So while start loc, step through the list from first to last. Okay, we'll go to that. Make this a little wider for you. Just so we don't miss anything. 7 1. Step through the list from first to last position. Current value equals sort list. Pick off the value to be placed into the sorted list. Alright? So the very first value that we're going to add to the sorted list apparently is going to be 2. Fantastic. And you know why that is? Because guess what's already in our sorted list? 9! It's a list of 1 that's already sorted. Fantastic. That's wonderful. Now we're going to stick 2 into our sorted list. Okay, well, that sounds cool. Okay. J equals start loc. Alright. What is start loc currently? 1. Okay, not really the best overall variable name, but we'll look at it for right now. Got it? Point to the end of the list of sorted numbers. Huh. So J points right here. Is this the end of the list of sorted numbers? The answer is yeah, because 9 was already on our list by default. Now we're planning on adding 2 to our sorted list, right? Sorted, our list is only really 2 items long. Okay. While J is greater than 0, J greater than 0 right now, yes it is. And sort list J minus 1. So J is 1, sort list J minus 1 will be sort list 0. That means that we're pointing to what? 9. Well, J is greater than 0 and 9 is greater than current value. What's current value? 2. So is 9 greater than 2? So let's see, J is greater than 0 and sort list 9 is greater than 2 if pair out of sequence. So basically this thing is 9 greater than 2, right? Those are out of sequence, that is correct. Then sort list J equals sort list J minus 1. So sort list J, which is this one, right? Equals sort list J minus 1, which is this one. I don't know if I can. Okay. J equals J minus 1. Point to the next spot in the list of sorted values. So J equals J minus 1. So J is at 1, minus 1, 0. While J is greater than 0, what's J right now? Excuse me? What's J? On the board, what's J?
0.
So while J is greater than 0, is that true or false? While J is greater than 0?
False.
False. So we're done with that while loop. Thank you very much. Don't really care about you. Sort list J equals current value. So sort list J is equal to current value. What's in current value? So did we just switch the 9 and the 2? Boop, all done. Start loc equals start loc plus 1. So it was 1, and now it's 2. And now we're going to go back up to our main loop, where we start doing the whole thing again. Okay? And what we're going to do is we're going to go stepping along here. So now this is our sorted list. We're all good with that. We know that that is completely sorted. So now what we're going to do is we're going to grab the next number, which in this particular case is going to be 7. And the question is where should 7 drop into there? Where should 7 go? Between 2 and 9, exactly right. So what we'll probably end up doing is scooting 9 over and flipping 7 into it when we're good to go, right? Is that different from the other 2 ways we did this? Yeah, it is. Do we think it's going to work? I don't know. Give it a shot. So we started with the scrambled list, we ran it, we got the perfectly sorted list. Woohoo! Insertion sort seems to work, right? So it's really 3 different ways to do exactly the same thing. Okay? Under different circumstances, these algorithms work better for different types of data, right? They are all big O of n squared complexity, which means in the worst possible case, the number of passes that it could take would be the number of elements in the pass, n squared. Okay? There's much better sorting algorithms. Okay? Big O of n is generally what the better ones do. In other words, they will have to go through the list once and only once, and you have a completely sorted list. Great, that's fantastic, that's wonderful. Those algorithms are actually considerably more complicated than the ones that we went through today. So I'm not going to hassle you with these. These are perfectly good. They work just fine. There's no problems with them whatsoever. Okay? Now remember, in homework number 2, there's at least 2 different opportunities for you to sort the data that you have.
So these still work with 2 the same numbers, right?
These would still work if you had 2. So in other words, if I had 0, 0, would not be a problem whatsoever. Yeah, let's stick them right next to each other, right? Because they'll be always less than the other number, right? Yeah, so now the one thing I probably can't tell you is, did the first 0 go here, or did the second 0 go? The 0 is the 0, it's all exactly the same. And I bet it always ends up exactly the same way. I think the second one will always be to the right, probably. But that's a separate issue. But yeah, so if you have duplicate numbers, 1, 1, 6, 6, 5, 5, something like that, they will end up together when you do this type of sort. Won't be a problem whatsoever. So in the homework problem that you have to sort people by last name. You have to do it alphabetically. Then you have to calculate their age, which you did last time, so that should not be too hard to do. But then you have to sort your patients by age. And print it out. Here it comes, here it comes, here it comes. In reverse chronological order. That means you print who first. The reverse chronological order. No. Oldest first. The oldest first. So that means you're going to have to sort based on age. What that also probably means, and I don't want to put any words in your mouth or anything like that, is that what you're probably going to have to do is for each one of your patients, you're going to have to determine how old they are, which you did in the last homework, right? But now, once you have that number, what are you going to have to do with it? You're going to have to what with it? Add it to what? To the list for that patient, right? When you calculate their age, it becomes part of the patient's data, right? And you probably want to add it to the record. And after you've added it to the record, then can you use it to sort all the records? Yeah, seems like it, doesn't it? I mean, once again, we've talked about this before. You know, I've given you, what have I given you? I've really given you a sequence of what, maybe like 12 Python statements, which is basically your paintbrushes, your paints, and your canvas. And homework number 2 is an opportunity for you to once again create a beautiful portrait for me. Okay? The beautiful portrait that you choose to create will be much different from the one that I created. Okay? But with a little luck, you'll produce exactly the same output that mine does. Sound like a fair challenge? Fantastic. All right, so what did we cover today? Bubble sort, selection sort, insertion sort. what's the important thing that you take away from this? First off, we went through how it works. No magic there. I mean, it's just really grinding away on the numbers. That's all it's actually doing. These all do exactly the same thing. Give them an unsorted list, and they will produce a sorted list. How they actually go about doing it is completely different. Okay? They all have their advantages and disadvantages. They're all relatively simple. However, I will give you the code that we ran in class today. You are more than welcome to do with it as you wish. Okay? Next time, we're going to cover list part 2. Give you more information about lists. And that's it. We're done. Thank you very much. I will see you on Thursday.